My name is Jim Evans. I'm with the Metallic Coatings Group at AK Steel's Research and Innovation Center, and I provide technical support for aluminized Type II products produced at the Middletown Works. The following is an explanation of the limitations of handheld coating thickness devices when applied to aluminized Type II coatings. The important thing to observe on these images and these figures is the differences between the metallographic coating structure of the 16 and the 14 gauge versus the 10 and the 12 gauge. The major takeaway is that the alloy layer, which is the intermetallic coating between the steel and the free aluminum, is thinner on the lighter gauge products. Somewhere between 10 and 13 microns is typical for a 16 or a 14 gauge product. Whereas on the 12 gauge product, the coating can be anywhere from 17 to 20 microns thick. Another important characteristic is that the alloy layer, which is a stoichiometric variable composition of iron aluminide, a little less than twice the density of the free aluminum layer. Free aluminum layer is about 2.7 specific gravity. The specific gravity of the alloy is between 4 and 4.5. So the thicker that alloy layer, the more dense the net coating becomes. You have to channel your inner Archimedes. On the thicker coatings in the lower images, you see a thinner free aluminum layer and a thicker alloy layer because of the product's cooling characteristics coming out of the pot. Both of these images, while they are very distinct in appearance, are both compliant 1 ounce coatings. I just want to make sure you understand that when these dry film thickness gauges read, they read the first interface from the surface to the alloy layer. And so they'll see perhaps 30, 40, or 50 microns, depending on where you measure, on a 16 gauge, but may only see 18 to 20 or maybe 25 or 30 microns on the free aluminum and the alloy layer on the heavier thickness products. And that's because of the thicker alloy presence. On this comparison, we're doing weigh strip weigh data using the AASHTO T213 Section 6 Method A, which is the hot sodium hydroxide, rinse, cool, room temperature, concentrated hydrochloric, rinse and dry. We're using that as the umpire for coating weight via weigh strip weigh. The graphical representations present on this slide show the variation that exists when we took 10 measurements per side per coupon and ran the weigh strip weigh data. We would get a final math shakeout of a 3.36 to 4.01 grams per square meter of coating per micron of measured thickness. I say that slowly, but that's grams per meter squared per micron of measured thickness. That's a pretty big window, and you can understand why we don't see these as umpires, but rather guidelines. These devices are good for comparing the coating to locations similar in the pipe. We like them for measuring the 12 o'clock position versus the 6 o'clock position, getting an average of several readings at the 12 o'clock assumed to be pristine and new, and the 6 o'clock, which is the weathered condition for the aged pipe. That's where these devices give us the most useful information. But to use it as an umpire that says this pipe is no good because the coating is too thin, it doesn't take into consideration the variability that's present in the coating and the device. For more information about aluminized Type II for corrugated steel pipe applications, visit the NCSPA's website